In the cold, endless dark beyond Neptune, 5 lonely machines drift farther from home than any human has ever traveled. They are not alive, yet they carry our voices, our music and our questions into the void. They are silent witnesses to the story of our species, moving at thousands of miles per hour toward the unknown. Each one began as a fragile bundle of wires and metal launched on rockets decades ago. But today they are our first true ambassadors to the galaxy. Voyager 1, for example, has now passed more than 14 billion miles from Earth. Its faint signal takes over 22 hours to reach us, a whisper across an ocean of emptiness. To call that distance unimaginable would be an understatement. Yet this tiny spacecraft, no heavier than a small car and less powerful than a smartphone, achieved something humanity had dreamed of for centuries, leaving the safety of the sun's embrace and entering interstellar space. But this wasn't simply a symbolic crossing. As it pierced the boundary of the heliosphere, Voyager 1 revealed that the edge of our solar system isn't a clean border, but a chaotic battlefield where the solar wind collides with the galaxy itself. Imagine a river slamming into an ocean, currents smashing together, twisting and folding into turbulence that stretches millions of miles wide. That's where Voyager now sails, not into silence, but into storms of radiation born in the explosions of long-dead stars. And here's the shocking part. Instead of thinning into emptiness, space out there is denser than anyone expected. Scientists had predicted a desert with barely 1 particle per sugar cube volume, but Voyager's instruments proved otherwise. Suddenly, humanity had to rethink how galaxies breathe, how stars form, and how fragile our protective bubble really is. For decades, these spacecraft have upended our understanding of the universe. The Voyagers alone exposed volcanic moons, erupting with sulfur plumes, hundreds of miles high, discovered delicate rings around Jupiter, invisible from Earth, and showed us oceans hidden beneath icy shells, where alien life might be waiting. They proved that Saturn's rings are not just static ornaments, but living systems sculpted by tiny moons that act like cosmic shepherds, herding ice and dust into elegant patterns. They listened to Jupiter's thunderstorms scream across space, with lightning bolts bigger than continents. They captured the haunting image of Earth as a pale blue dot, a fragile speck of light suspended in a sunbeam, smaller than a grain of sand against the infinite black. And yet, as breathtaking as those discoveries were, the story isn't over. Even now, these robotic scouts continue racing outward, every second adding another 11 miles to their journey. Their nuclear hearts grow weaker with time, their voices fainter, but they still send back messages about a realm humanity has never entered before. The space they travel is colder than anything naturally found on Earth, just a few degrees above absolute zero, a place where atoms barely move and the rules of matter begin to blur. It is a cosmic freezer that preserves them, perhaps for millions of years, drifting long after our civilization is gone. Somewhere out there, millions of years from now, another intelligence might find them, and on their golden records, hear our greetings, our music, our heartbeat. These aren't just missions, they are the first steps of humanity escaping the cradle of Earth. They remind us how small we are, but also how far we dare to reach. When Voyager 1 crossed into interstellar space in 2012, humanity officially became an interstellar species, not in flesh and blood, but through the fragile shell of a spacecraft launched nearly 4 decades earlier. The crossing itself was not a dramatic line marked on a cosmic map, but an invisible frontier called the heliopause, the boundary where the solar wind streams of charged particles blown out by our sun finally loses its strength against the crushing pressure of the interstellar medium. For years, scientists debated where this border would lie. Some imagined it would be a gradual fading. Others believed it would be like a cliff, sudden and unmistakable. But what Voyager revealed was far stranger than anyone predicted. Instead of thinning into empty space, the region beyond our solar bubble was denser than expected, almost as if Voyager had run into a cosmic fog rather than breaking free into open air. This discovery stunned astrophysicists because it rewrote what they thought they knew about the galaxy. Interstellar space, long imagined as a silent void, turned out to be more turbulent, more alive than the emptiness we see in science fiction. The data showed particles colliding in chaotic ways, magnetic fields twisting and folding like invisible waves, and radiation levels far higher than what fills the solar system. Voyager became a sailor not crossing into calm waters, but steering into a storm. The fact that such a small, outdated spacecraft could make measurements that shook the foundations of astrophysics was almost as remarkable as the discovery itself. A probe launched with 1970s technology had revealed something new about how galaxies breathe. But Voyager's crossing was not just a scientific triumph. It was a philosophical one. For billions of years, every speck of Earth's dust, every drop of its water, every living creature had been bound inside the sun's domain. The heliosphere, this vast bubble inflated by solar winds, was our invisible cage. Voyager 1 was the first object to escape it. In a sense, it marked the moment when humanity's presence extended beyond the reach of our star, leaving a footprint, however small, on the canvas of the Milky Way itself. And even though no human has traveled farther than the moon, this tiny spacecraft had carried us farther than any dreamer, storyteller, or explorer in history. The instruments aboard Voyager detected strange cosmic rays from ancient supernovae, particles flung across the galaxy at near light speed. These are the embers of stars that exploded millions of years ago, still traveling through space like bullets, and Voyager was now enduring them directly. The spacecraft also revealed that the sun's protective bubble is not static. It breathes, expanding and contracting like a living lung, shifting its shape depending on solar activity. When the sun flares, the bubble swells. When it quiets, the bubble shrinks, leaving more of the solar system exposed to the violence of the galaxy. For scientists, this was more than just an interesting detail, it was a warning. Our protective shield is fragile, dynamic, and temporary. The crossing of the heliopause raised unsettling questions. If interstellar space is denser than expected, what does that mean for our understanding of how stars form, how cosmic rays travel, or how galactic magnetic fields are structured? If our solar system's protective shield can breathe, does that mean other star systems are more vulnerable than we thought? Could civilizations elsewhere be erased simply because their parent star's bubble was weaker than ours? Suddenly, Voyager's lonely flight wasn't just about humanity's curiosity. It was about survival. The data it sent back revealed that the galaxy is not a friendly ocean waiting to be explored, but a turbulent sea of radiation, pressure, and storms. And yet, despite the danger, there was something profoundly human about that moment. A machine built by engineers who never expected it to outlive them was still pushing forward, blind, battered, and ancient by technological standards, yet faithfully whispering back secrets from the edge of the unknown. It reminded us that exploration is never about comfort or certainty, but about daring to step where no one has stepped before. Voyager had gone beyond the sun, into a region untouched by life, carrying the fingerprints of humanity into a realm we had only imagined in myths. But this was only the beginning of its revelations, because the closer it looked at the worlds along the way, the more rules it would break. Before Voyager ever crossed into interstellar space, its greatest shocks came much closer to home, when it swept past the giant planets of our solar system and revealed worlds stranger than anything scientists had dared to imagine. In 1979, Voyager 1 approached Jupiter, the largest planet in our neighborhood, and what it found shattered the rules of planetary science. One of Jupiter's moons, Io, was expected to be a dead, frozen rock like our own moon. Instead, the spacecraft captured images of colossal volcanoes erupting with fountains of molten sulfur shooting hundreds of miles high into space. The surface of Io was alive with lava lakes, erupting plumes, and a landscape constantly reshaped by fire. No one had predicted this. Until that moment, volcanism on Earth was considered unique and relatively rare in the solar system. Voyager showed that even distant, icy moons could harbor internal heat, powerful enough to tear their crusts open. This discovery rewrote textbooks overnight and hinted that the universe might be far more dynamic than we believed. And Io was only the beginning. Another of Jupiter's moons, Europa, displayed an icy surface covered in cracks and ridges that looked eerily familiar. Scientists realized that these patterns could only form if something below the ice was moving, something liquid. The shocking possibility emerged that Europa might hide an entire ocean beneath its frozen shell, kept warm by tidal forces tugging at the moon's interior. An ocean that large, sealed off for billions of years, could be one of the best places in the solar system to search for alien life. Once again, Voyager had taken what seemed like a barren, dead world and turned it into a place of haunting potential. Jupiter itself was no less surprising. Voyager's cameras revealed lightning storms larger than Earth, raging across its atmosphere with unimaginable violence. Its famous Great Red Spot, long thought to be a simple storm, was revealed as a vortex more complex and long-lived than any hurricane on Earth. The spacecraft discovered faint, delicate rings around Jupiter, invisible from Earth, but proving that Saturn was not the only planet to wear such adornments. Each image Voyager sent home reminded us that our assumptions about the solar system were embarrassingly narrow, based on the single example of Earth and a handful of glimpses through telescopes. The truth was that the solar system was alive with activity, more alien and more varied than anyone had imagined. The discoveries didn't stop with Jupiter. As Voyager moved on to Saturn, it uncovered new moons, atmospheric mysteries, and ring structures that defied explanation. But before diving into those revelations, the lessons from Jupiter alone were enough to change the way we look at the universe. If Io could erupt with volcanic fury, and Europa could cradle an ocean beneath its ice, then where else might the unexpected be waiting? What other moons, planets, or distant objects might harbor secrets just as profound? Voyager taught us to expect the impossible, to see every world not as a dead rock, but as a potential stage for drama, beauty, and maybe even life. The closer Voyager looked, the stranger everything became. And if Jupiter was enough to break the rules, Saturn would completely rewrite them. When Voyager reached Saturn in 1980, scientists expected beauty but not mystery. The planet's iconic rings had fascinated astronomers for centuries, yet most assumed they were static, simple structures, thin bands of ice and dust, leftovers from some ancient collision. What Voyager uncovered instead was a living system, a world of motion, tension, and stinge phenomena that seemed to obey rules no one had written. The F-ring, a narrow band on Saturn's edge, was supposed to be smooth and uniform. Instead, Voyager showed it twisted and braided, its structure resembling strands of rope pulled and tangled by invisible hands. This bizarre pattern turned out to be the work of shepherd moons, tiny bodies orbiting near the ring, tugging and pushing the icy particles into order. These moons acted like cosmic sheepdogs, corralling trillions of fragments across tens of thousands of miles into intricate shifting patterns. Suddenly, Saturn's rings were no longer passive ornaments, but dynamic ecosystems shaped by forces as delicate as gravity and as mysterious as magnetism. Even stranger were the so-called spokes that appeared in Saturn's rings. Voyager captured images of dark, radial streaks that seemed to emerge and vanish without warning. These spokes, stretching thousands of kilometers across the rings, weren't made of solid material, but charged particles levitating above the icy surface, lifted by Saturn's immense magnetic field. The sight of entire portions of the rings appearing to float, shimmering like ghostly shadows, challenged scientists' understanding of how planetary rings could behave. To this day, these spokes remain one of Saturn's great puzzles, a phenomenon not yet fully explained, even with modern observations from later missions like Cassini. Saturn's moons, too, defied expectations. Enceladus, a tiny ice-covered world only about 300 miles across, should have been geologically dead. Yet Voyager spotted signs of a smooth, bright surface that hinted at something active beneath. Decades later, Cassini would confirm that Enceladus harbors geysers, spraying water vapor into space from a hidden subsurface ocean. But it was Voyager that first pointed to the possibility, forcing scientists to reconsider the assumption that small icy moons could be lifeless. Even Titan, Saturn's largest moon, teased Voyager's cameras with its dense, orange atmosphere. The spacecraft couldn't see the surface through the haze, but the very fact that Titan had a thick atmosphere, denser than Earth's, was a revelation. It hinted at complex chemistry and perhaps even processes that might resemble the early Earth before life began. Every discovery at Saturn carried the same message. The solar system is not a museum of static objects, frozen in time, but a stage of constant motion and surprise. The rings that looked like solid disks from Earth turned out to be billions of dancing ice particles, sculpted by invisible forces. Moons that should have been dead revealed the fingerprints of hidden oceans and active surfaces. Saturn itself, with its storms, auroras, and magnetic field, became less a distant gas giant and more a laboratory of physics, unlike anything found at home. Voyager transformed Saturn from a symbol of cosmic beauty into a frontier of unanswered questions. But perhaps the most haunting lesson came not from what Voyager saw, but from what it suggested. If rings can be alive with movement, if tiny moons can hide oceans, if atmospheres can cloak secrets, then what else might be hiding across the solar system, just out of sight? Saturn wasn't just rewriting the rules, it was daring us to imagine what mysteries lay ahead. And as Voyager pressed onward toward the dark outer reaches, it would stumble upon enigmas not just in the planets it passed, but in its own behavior, mysteries that would baffle scientists for decades. As the Voyagers and their predecessors, the Pioneer spacecraft, drifted farther from Earth, they didn't just reveal mysteries in the planets they visited. They became mysteries themselves. Pioneer 10 and Pioneer 11 were the first human-made objects sent on trajectories that would eventually leave the solar system, trailblazers that opened the path for Voyager. But as mission controllers tracked their fading signals, something strange began to happen. Both probes were slowing down in a way no one could explain. It was subtle, so slight it amounted to the probes drifting about 250,000 miles off course after decades of travel. But in the precise world of space navigation, this was enormous. It looked as though an invisible hand was tugging them back toward the sun, resisting their escape. This became known as the Pioneer anomaly, and for years it baffled the best scientific minds. Was there some undiscovered property of gravity at play, a hidden flaw in Einstein's general relativity? Could there be exotic, dark matter spread unevenly through the solar system, subtly pulling at the spacecraft? Or was it evidence of some new, unseen force of physics? The idea that two tiny probes, each about the size of a desk, could challenge the very foundations of our understanding of the universe was both thrilling and unsettling. Speculation ran wild. Entire conferences were dedicated to the anomaly, papers were published exploring radical theories, and some even suggested it might be the faint signature of something profoundly alien. Yet, the truth, as it turned out, was far less exotic, but no less fascinating. After years of careful analysis, scientists realized that the spacecraft themselves were the source of the mystery. Heat generated by their radioactive power sources and electronics was radiating out unevenly, creating a tiny but constant recoil effect. Essentially, the probes were being pushed back by their own heat. In other words, it wasn't dark matter or new physics slowing them down, but the simple physics of thermal radiation. The anomaly was solved not by rewriting the laws of the universe, but by recognizing the spacecraft as imperfect little heaters drifting through the void. Still, the Pioneer anomaly left a deep impression. It was a reminder of how fragile and uncertain our grip on cosmic truth really is. For decades, two small spacecraft had whispered a puzzle that made even the most confident scientists hesitate. And though the explanation turned out to be humble, the anomaly proved something important. Even the smallest details can matter when we are trying to understand the universe. A subtle push from waste heat might not sound exciting, but it showed that the cosmos hides its truths in layers, waiting for us to peel them back with patience and precision. Meanwhile, the Voyagers themselves were not immune to strangeness. Their instruments occasionally picked up signals that defied immediate explanation: eerie plasma waves, mysterious magnetic fluctuations, and bursts of particles that seemed to arrive from nowhere. Each time, scientists were forced to ask whether they were glimpsing something genuinely new or simply running into the limits of their machines. In either case, the lesson was clear: the act of exploration is never predictable. You can launch a spacecraft with the best models and expectations, but the universe always has surprises waiting. The Pioneer anomaly may not have rewritten physics, but it revealed just how close we often are to the edge of the unknown. It showed us that even a desk-sized probe, long forgotten by the public, could shake the confidence of modern science. And it prepared us for the fact that, as Voyager moved beyond Saturn and pressed deeper into the darkness, the universe was not going to let go of its secrets easily. The planets had already defied our imagination. The spacecraft themselves had become mysteries, and what lay beyond them was a frontier of riddles, stretching all the way to the edge of the solar system and beyond. By the time New Horizons reached Pluto in 2015, many scientists had quietly lowered their expectations. For decades, Pluto had been dismissed as a frozen rock at the edge of the solar system, a relic of planetary formation, with little to offer beyond a pockmarked, icy surface. It had even been demoted from planet to dwarf planet, an astronomical afterthought in the Kuiper Belt. But when the first images from New Horizons arrived, they stunned the world. Instead of a dead world, Pluto revealed itself as a place alive with geological drama. Towering mountains of ice rose as high as the Rockies, casting shadows across plains of frozen nitrogen that appeared as smooth as glass. Vast glaciers stretched across the landscape, not of water but of exotic ices, flowing slowly in patterns eerily similar to glaciers on Earth. And then came the most shocking discovery: signs of cryovolcanoes, massive icy mountains that may have erupted with slurries of water and ammonia, reshaping Pluto's surface long after scientists thought it should have gone cold and silent. Even more surprising was the evidence that Pluto might hide a subsurface ocean. Beneath the thick crust of ice, there could be liquid water kept warm by radioactive elements in the planet's core. If true, that means Pluto, a world billions of miles from the Sun, smaller than our own moon, might harbor one of the key ingredients for life. Suddenly, the solar system's frozen frontier didn't seem so barren after all. New Horizons revealed Pluto as a living planet, reshaping itself in ways no one had expected, and in doing so, it reopened the question of how many other icy worlds might be hiding similar secrets. The mission didn't stop there. After Pluto, New Horizons continued into the Kuiper Belt, a vast region of icy bodies orbiting beyond Neptune. In 2019, it performed a flyby of Arakoth, a small, elongated world shaped like two spheres fused together, nicknamed the Cosmic Snowman. Arakoth turned out to be the most pristine object ever studied in the solar system, untouched since the dawn of planetary formation. Its smooth, undisturbed surface suggested that it had never been violently disrupted, offering scientists a rare glimpse into the earliest building blocks of planets. The discovery changed our understanding of how solar systems form. Instead of chaotic collisions, Arakoth hinted at a gentler process of gradual accumulation, like dust grains slowly sticking together until they become worlds. These findings showed that the Kuiper Belt isn't just a graveyard of frozen rocks, it's a treasure chest of information about the birth of planets, locked away for billions of years. New Horizons, like Voyager before it, reminded us that the farther we look, the more the universe defies our assumptions. What we thought would be dead turned out to be alive. What we thought would be simple turned out to be complex, and what we thought would be the end turned out to be the beginning of new questions. But the most haunting part of Pluto's story is what it represents about exploration itself. For nearly a century, Pluto was nothing more than a blurry smudge on telescopes, a point of light that barely moved against the background stars. Generations of scientists debated what it might be, wrote theories, argued over its importance, and in the end, only a spacecraft flying nearly 3 billion miles from Earth could reveal the truth. The lesson is as clear as it is humbling. The universe doesn't yield its secrets from a distance. You have to go there to risk, to send your machines into the dark, and to wait for the faint signals that travel across unimaginable distances to whisper the truth back home. New Horizons proved that exploration never ends. Just when we thought the solar system had no more surprises left, it handed us glaciers, volcanoes, oceans, and the untouched fossils of planetary birth. And yet, even as the spacecraft continued deeper into the Kuiper Belt, its discoveries raised another question that no one had fully prepared for. If we can find such complexity and vitality in a frozen dwarf planet, billions of miles away, what else is waiting beyond, still unseen, in the shadows of the galaxy? While the spacecraft revealed astonishing landscapes and baffling mysteries across the planets, perhaps their most enduring legacy isn't the data they gathered, but the messages they carry. Long before Voyager 1 and 2 crossed into interstellar space, their creators realized that these machines would outlive their missions, drifting silently through the galaxy long after their power sources failed. And so the engineers and scientists behind them decided to give the probes a second purpose, not only as scientific instruments, but as messengers of humanity. On the Pioneers, small metal plaques were attached, engraved with simple drawings, the outline of a man and a woman, the silhouette of our spacecraft, and a map showing the position of our sun relative to pulsars scattered across the galaxy. It was a cosmic postcard, a way of saying this is who we are, and this is where you can find us. The Voyagers carried something even more ambitious, the Golden Record. This copper disc, plated in gold, was designed to last 1 billion years in the vacuum of space. Etched onto it were instructions for how to play it, like a universal decoder, in case it ever landed in the hands or appendages of an alien intelligence. But what was on the record was even more extraordinary. Scientists, artists, and thinkers gathered the sounds and images they believed could represent the diversity of life on Earth. They included greetings in 55 human languages and one from a whale, music ranging from Bach to Chuck Berry, diagrams of DNA, images of forests, oceans and cities, and even the sound of a mother's kiss. In just 90 minutes of audio and 116 pictures, they attempted to capture the essence of humanity, compressed into a message for the stars. This act was more than scientific curiosity. It was a statement of hope. The Voyagers would drift for billions of years, long after human civilizations had risen and fallen, carrying proof that we existed. Even if Earth were destroyed, even if our species vanished, these records would survive, spinning through the galaxy as silent witnesses to our story. They became, in a sense, our immortality project. And yet, there is something haunting about them too. Imagine, millions of years from now, some alien civilization intercepting one of these craft. They might decipher our maps and trace them back to a star system where Earth once orbited. But what if by then there is no Earth as we know it? What if we are nothing more than a memory encoded on a golden disk drifting through the void? That paradox gives the golden records their power. They are both triumphant and tragic. Triumphant because they show we dared to speak to the universe, to send out a declaration that intelligence arose on a small blue planet and wished not to be alone. Tragic because they might endure far longer than our species itself, echoing across time even if no one is left to remember the moment of their launch. And perhaps that's the point. Perhaps the Voyagers are less about being found and more about the act of sending. In choosing to create the golden record, humanity declared itself a participant in the cosmic story, no longer content to be isolated, but eager to join a chorus of voices, even if we are the first to sing. It's easy to think of these records as simple curiosities, tucked away on machines that will never be found. But every time we look up at the night sky, we should remember that our music, our greetings and our laughter are already out there, carried beyond the sun's light, racing into eternity. The spacecraft may one day fall silent, their signals too faint for Earth to hear, but their messages will continue, their golden hearts beating forever in the cold. And as they drift farther into the galaxy, these messengers of humanity become more than spacecraft. They become monuments, reminders that even in the vast silence of space, we chose to speak. As Voyager crossed the boundary into interstellar space, scientists expected silence, a kind of cosmic emptiness where the sun's influence ended and the galaxies began. Instead, the spacecraft entered a realm far more hostile than anyone had imagined. The sun's bubble, the heliosphere, which shields us from much of the galaxy's radiation, was revealed to be fragile, expanding and shrinking like a giant lung. During periods of strong solar activity, it swells outward, deflecting cosmic rays, but when the sun quiets down, it contracts, leaving Earth and the other planets more exposed to the universe's ancient storms. Voyager's instruments proved that the very edge of our protective shield is constantly in flux, a reminder that the galaxy outside is not a calm sea, but a battlefield. One of the most shocking discoveries came when Voyager detected interstellar plasma waves, low, eerie vibrations from particles born in long-dead stars. These waves were stronger and denser than scientists predicted, as if the spacecraft had drifted into a storm made of invisible sound. Interstellar space wasn't just emptier, it was alive, humming with energy from supernovae that exploded millions of years ago. Every particle, every wave Voyager encountered carried a message from some cataclysmic event, the death cries of stars that once lit up the galaxy. The radiation levels were higher than expected, almost like a constant drizzle of bullets striking the spacecraft, and these were no ordinary particles. They were cosmic rays, fragments of atoms accelerated to near the speed of light, racing across the galaxy with enough power to rip through DNA and fry electronics. For Earth, These discoveries were more than just curiosities. They were warnings. Without the heliosphere, life as we know it would be nearly impossible. The galaxy is not a gentle place. It is violent, radioactive, and indifferent. The fact that our solar system drifts inside this protective bubble is the only reason complex organisms like us exist. Voyager showed us that our survival is balanced on a razor's edge, dependent on a shield we barely understood until recently. Even more unsettling were the strange behaviors of the magnetic fields at the boundary. Voyager detected fields that twisted and shifted in ways that didn't match existing models. Instead of a clean transition from solar influence to interstellar space, the spacecraft found a tangled mess, as though invisible threads of magnetism were woven together and pulling in conflicting directions. Some scientists described it as being trapped inside an invisible storm of rubber bands, snapping and twisting unpredictably. This chaotic magnetic frontier is not just a curiosity. It has direct consequences for the way cosmic radiation enters the solar system, and by extension how much of it reaches Earth. Each new measurement Voyager sent back painted the galaxy not as a welcoming frontier, but as an ancient war zone, still echoing with the energy of past battles. The sun shields us for now, but that shield is temporary, always breathing, always shifting. One day, far in the future, when the sun grows weaker and the heliosphere collapses, the Earth will be fully exposed to this storm. Voyager's data gives us a glimpse of that future, a reminder that our place in the galaxy is more precarious than we would like to believe. And yet, amid the danger, there is awe. Voyager didn't just find emptiness, it found a cosmic ocean alive with hidden currents and whispers from ancient stars. The spacecraft revealed that interstellar space is not a void, but a place of memory where the energy of the galaxy's past still moves and collides. The realization that we are shielded inside a bubble floating through a turbulent galaxy is both terrifying and humbling. It forces us to ask, how long will our shield hold? And what happens when it finally fails? But the greatest revelation wasn't just about the galaxy itself. It was about us, about our fragility, our reliance on invisible protections, and our desire to send machines into the storm anyway, to learn what waits beyond. And in one haunting image, Voyager captured the truth of our place in this hostile universe in a way no data could ever match. Amid all the discoveries, all the storms of plasma and strange worlds revealed, there is one image from Voyager that transcends science, becoming something closer to philosophy, even poetry. In 1990, as Voyager 1 prepared to shut down its cameras forever to save power, Carl Sagan convinced NASA to turn the spacecraft around one last time and take a family portrait of the solar system. From more than 3.7 billion miles away, the planets appeared as tiny specks of light scattered across the vastness, each one a faint glimmer against an infinite black canvas. Among them was Earth. No larger than a fraction of a pixel, a pale blue dot suspended in a beam of sunlight scattered by the camera lens. It was almost invisible, a smudge so small that it could have been mistaken for a dust particle on the screen. Yet it was everything. Every human who had ever lived, every war ever fought, every dream ever dreamt, all contained in that fragile mote of light. The pale blue dot image became Voyager's most enduring legacy, not because of its scientific value, but because of what it forced us to confront. We like to imagine ourselves as significant, central to the story of the cosmos, but here was undeniable evidence of our smallness. From that distance, Earth was not the center of anything. It was barely there at all. Sagan later wrote that the image reminded us of our responsibility, that the Earth is the only home we have, a tiny island adrift in a cosmic ocean, with no help coming from anywhere else. All our conflicts, our greed, Our divisions seemed absurd when reduced to a dot that could vanish if the camera shifted slightly. And yet, the power of that image lies not only in humility but in hope. That pale dot glowed, fragile but defiant, shining in the darkness. Against the unimaginable scale of the universe, our world was still alive, still home to billions of minds capable of curiosity, love, and exploration. The fact that we were able to send a machine across billions of miles, turn it back toward home, and capture that photograph was proof of something extraordinary. That smallness does not mean insignificance. In fact, it might mean the opposite. The universe is vast and violent, but within it, on a tiny dot of light, consciousness arose that could look outward and recognize itself. The pale blue dot became more than a picture. It became a mirror. It asked us to reconsider what matters, to see the futility of conquest, the urgency of protecting the only home we know. It transformed Voyager from a scientific mission into a moral compass, pointing not only outward but inward, reminding us of our fragile unity. No spacecraft before or since has delivered such a profound message with a single image. And yet, the haunting part of the pale blue dot is how easily it could vanish. From the perspective of interstellar space, Earth is barely a whisper, a ghost of light among countless others. If Voyager had been a little farther away, if the angle of sunlight had shifted slightly, we would never have seen it at all. The image is both a celebration and a warning, a celebration of our ability to capture it, and a warning that our world's survival is far from guaranteed. In that one photograph, the universe told us a story about ourselves. It told us we are small, but we are also rare. We are fragile, but we are luminous. We are temporary, but we are capable of leaving messages that last longer than we do. Voyager gave us many discoveries, but in that pale dot, it gave us something even more precious: perspective. A reminder that our greatest journey may not be into space, but into an understanding of what it means to be human, here and now, on the only dot we have. As the Voyagers continue their silent drift into the dark, billions of miles from the sun, they remind us that exploration is never really about reaching an endpoint. There is no finish line out there, no border in space that marks a final victory. Instead, there is only the journey, a steady push into the unknown, guided by curiosity and fueled by the belief that even the smallest machine can carry the weight of humanity's questions. Each faint signal that still reaches Earth, delayed by more than 22 hours of light travel time, is a whisper from the edge of time and space, a fragile reminder that our story is still being written out there in the cold. When those signals finally fade, when the last instrument goes quiet, the Voyagers will not die in the usual sense. They will simply keep going, carrying their golden hearts into the galaxy, outliving the civilizations that built them, outliving perhaps the species that dared to launch them. The legacy of these spacecraft is not only in the scientific treasures they uncovered, volcanoes on Io, oceans on Europa, braided rings of Saturn, the icy mountains of Pluto, but in the way they forced us to confront questions bigger than science. They made us realize that the solar system is not a frozen museum, but a living, restless place. They showed us that Earth is not the center of the story, but a dot, fragile and pale, suspended in an ocean of black. They proved that exploration is not just about finding answers, but about finding better questions. And above all, they showed us that we are capable of reaching beyond ourselves, beyond our fears, beyond even the protective bubble of our sun, to touch the galaxy itself. When future civilizations, human or otherwise, look back on this moment in history, they may not remember our wars, our borders, or our arguments. They may not remember our technologies, our skyscrapers, or our monuments, all of which will crumble into dust. But they may find two small spacecraft drifting between the stars, carrying greetings in 55 languages, music from across cultures, and the sounds of our planet's heartbeat. They may decode those golden records and learn that once upon a time, on a tiny world circling a yellow star, there lived a species that longed to be more than just survivors. A species that longed to connect. A species that looked into the void and dared to say, "We are here." That is the true triumph of the Voyager mission. It wasn't just about exploring other worlds. It was about discovering ourselves, about realizing that our significance doesn't come from size or power, but from perspective, from the courage to send our voices into a silence that might never answer back. Voyager turned the universe into a mirror, showing us our fragility and our strength, our smallness and our capacity for wonder. Even now, as they travel farther than any human creation has ever gone, the Voyagers continue to teach us something profound, that exploration has no end. Long after their cameras went dark, long after their instruments fall silent, their journey continues, and so does ours, because in every mile they travel, in every faint signal they send, in every story we tell about them, the Voyagers remind us of the most important truth of all, that even in the vast, indifferent darkness of the cosmos, we are capable of leaving a light behind.